Welcome, my name is Craven. I'm with Ophir Photonics, and we're here on the SPIE DSS 2016 trade show floor. Today we're going to discuss co-alignment of visible, near-infrared, and infrared laser beams. Pyroelectric camera arrays are ideal for aligning these multi-spectrum sources. Coupled with beam profiling software, it is an effective tool and quite easy to do. For the purposes of demonstration, I have a simple laser pointer and a silicon CCD camera that we'll be using to emulate the three sources coupled with some beam profiling software. So the first thing we need to do is define the axes that we're going to align to. And the way we're going to do that is we're going to use the initial beam or the first beam as the primary, set the camera origin around that beam, and then proceed from there. Again, to simulate, we're going to use a laser pointer in the camera, which I will activate and position on our screen. Let's, for argument's sake, say that this is your primary beam. This is the position you've chosen on the camera. And then from here, we're going to identify this either by its centroid or its peak. In this case, I'm going to choose centroid. It's activated. And to orientate this to the camera, we're going to define this centroid, which is shown here, as the origin of the camera. So now we've established the axes that we're going to be aligning to. Again, for argument's sake, let's say we're turning on beam number 2, which we'll bring onto the camera. So here we have a simulation of beam number 2, and as you can see, its position is also marked with the crosshair and its centroid. And here we can determine its location in millimeters relative to the origin that we established earlier. Several ways you can do this. You can tune it live and monitor the numbers, or you can take advantage of some tools such as Passfail criteria. For example, we could set a maximum deviation that we want of, let's say, 1 millimeter. We'll do that on both X and Y. And again, as you tuning, you can see those values changing. So with the pass-fail criteria, it makes the alignment relatively easy. And now we have values of both centroid X and Y that are in green, indicating we're within spec. We could also, in this case, we set a maximum deviation. We could also have a minimum established as well. Another option to make life a little easier is to include a strip chart, which we can use during the alignment process and to see in so we can use these strip charts to see how we are positioned to the centroid in real time. You can see that here. You'll notice that there's also the red defining line indicating what's within spec and what's out of spec. So in this case, this is beam number 2. We're within the millimeter that we established for the centroid. And what we're going to do here is define its location using a cursor. Place that on the centroid of that beam. And now we have established the origin of the camera from primary beam and the position of beam number 2 relative to that origin within the millimeter specification that we define. Now we'll turn on beam number 3. Again, simulating with the same laser pointer. So here we have a representation of beam 3 relative to the camera origin we already established. And you can see we're within the millimeter tolerance that we created here, both in the X and the Y direction. And its current centroid is located at that crosshair. Now you get a visual representation of what all three beams look like in the far field. You have the origin, the crosshair, and the cursor. And if needed, you can measure between beams 2 and beam 3 using a centroid to crosshair value. So now we have a visual representation of beam number 3 as it relates to the primary axis we established with beam 1, which is the origin of the camera, shown here by this red circle. We have the cursor identifying where beam 2 was positioned, and now we have the crosshair showing where beam 3 is positioned relative to not only the origin of the camera, but also using a cursor to crosshair value, we can see the distance between beams 2 and 3. So here we've just simulated the co-alignment of 3 laser beams of 3 different wavelengths spanning from UV, deep UV, to far infrared using our pyroelectric camera and beam gauge software. Thank you for your time.